Everyone thinks they know how the Americas were populated. Walk across Beringia. Follow the ice. Simple migration, simple story. Except the DNA doesn't agree. Genetic markers found in certain indigenous peoples of the Americas carry signatures that trace back to island Southeast Asia, specifically to populations now living in the Philippines, not Siberia, not Mongolia. The Philippines, a beautiful, tidy theory about one single land bridge, suddenly looks a lot less tidy. And the people who first noticed this weren't the famous geneticists whose names fill the headlines. They were lab technicians, quiet researchers, the ones who stare at haplogroup charts until 3 in the morning, noticing what others scroll past. Think about what it means to be the person who spots the anomaly. You're not the principal investigator. Your name won't appear first on the paper. You might be a graduate student running mitochondrial DNA extractions in a windowless lab somewhere in a university basement. And one night, you see a pattern that shouldn't be there. A maternal lineage connecting populations separated by the largest ocean on Earth. Do you trust your own eyes, or do you assume you've made a mistake? This is where the story begins, not with a grand announcement, with doubt. The dominant model for populating the Americas has been the Beringia hypothesis. During the last ice age, lower sea levels exposed a land bridge between Siberia and Alaska. Humans walked across. They spread southward, case closed, textbooks printed, curriculum approved. For decades, this narrative held firm. It was elegant, clean, and it explained a great deal, but not everything. Certain haplogroups found among indigenous peoples in Central and South America don't fit the expected Siberian profile. Researchers studying mitochondrial DNA, the genetic material passed from mother to child, identified lineages with deep roots in island Southeast Asia. These aren't vague similarities. The genetic signatures point to ancestral populations connected to what we now call the Philippines and surrounding archipelagos. The connection is specific enough that multiple independent studies have flagged it. So how? The Pacific Ocean is enormous. We're talking about thousands of miles of open water separating the Philippine archipelago from the coasts of the Americas. Could ancient peoples have crossed it? And if this evidence is so compelling, why isn't it in every classroom? Now pay attention. The answer to that second question has less to do with conspiracy and more to do with something profoundly human. Inertia. Consider the position of a textbook editor, not the author, the editor. The person whose job is to decide what stays and what gets cut. You've got a curriculum framework approved by a board. You've got page limits. You've got a narrative that works, that teachers already know how to teach. Now someone hands you a peer-reviewed paper suggesting that the story of human migration to the Americas might involve seafaring peoples from Southeast Asia. What do you do with that? You'd need to rewrite entire chapters. You'd need to train teachers on new material. You'd need to convince a review board that the old model is incomplete. Most editors, facing that mountain of institutional friction, make a practical choice. They leave the chapter alone. The information doesn't get deleted so much as it never gets added. The distinction matters, but the genetics keep whispering. One of the key pieces of evidence involves Haplogroup E, a mitochondrial lineage found at notable frequencies among certain populations in island Southeast Asia and, strangely, among some indigenous groups in the Americas. The distribution pattern doesn't match a simple north-to-south migration from Beringia. It suggests a different route, a coastal route, perhaps even a transoceanic one. Now the argument against this is strong, and it deserves honest consideration. Critics point out that genetic similarities can arise through convergent evolution, through ancient shared ancestry that predates any migration to the Americas, or through statistical noise in small sample sizes. Some researchers argue that the Southeast Asian genetic signatures found in the Americas could reflect a very old branching point in human history, one that occurred before populations split into distinct geographic groups. Under this reading, Filipino and indigenous American DNA share markers not because of direct contact, but because of a common ancestor tens of thousands of years ago. That's a reasonable position. It's cautious. It respects the complexity of population genetics. All right, but it doesn't fully explain the pattern. If you found this perspective thought-provoking, take a moment to subscribe and leave a like. This channel exists to surface the stories that mainstream narratives tend to flatten. Your support helps us keep digging. Here's what the cautious interpretation struggles with. The genetic markers in question aren't evenly distributed across all indigenous American populations. They cluster, they appear in specific communities along coastal regions, particularly in South America. If the shared ancestry were simply an ancient common root, you'd expect a more diffuse distribution. The clustering suggests something more targeted, something that looks like actual migration or contact along a specific pathway. And this is where the invisible workers of science become crucial again. The people who do the painstaking work of sampling, cataloging, and cross-referencing genetic data from dozens of populations across multiple continents. These aren't household names. They're postdoctoral researchers. They're indigenous community liaisons who spend years building trust so that genetic sampling can be conducted ethically. They're bioinformatics specialists writing code to compare sequences across databases that contain millions of entries. Without their labor, the anomaly in the data would never surface. The famous geneticist gets the interview. The person who flagged the irregular haplogroup gets a line in the acknowledgments section. Maybe. What kind of vessel could have carried people across the Pacific? This question haunted maritime archaeologists for decades. The Philippine archipelago has a deep tradition of boat building stretching back thousands of years. The balangay, a large plank-built boat, has been documented archaeologically to periods as early as the 4th century. But the seafaring tradition is older than any single vessel type. Austronesian peoples, the broader linguistic and cultural family that includes Filipinos, were among the most accomplished ocean voyagers in human history. They colonized Madagascar off the coast of Africa. They reached the remote islands of Polynesia. The idea that some of them could have reached the Americas isn't wild speculation. It's a logical extension of demonstrated capability. The counterargument here focuses on evidence of arrival rather than capability. Yes, Austronesian peoples could build seaworthy boats. Yes, they navigated vast stretches of ocean. But where are the archaeological traces on American shores? Where are the Austronesian-style artifacts, the boat fragments, the settlement patterns? Absence of evidence isn't evidence of absence, but in archaeology, you need physical proof to move from hypothesis to accepted theory. Fair point, devastatingly fair. Yet consider who does archaeological fieldwork in coastal South America. Consider who decides where to dig. Funding bodies prioritize sites connected to established narratives. A researcher proposing to excavate a coastal site looking for evidence of Southeast Asian contact faces an uphill battle for grants, for institutional support, for publication in prestigious journals. The absence of archaeological evidence might partly reflect the absence of anyone looking for it in the right places. The person who writes the grant proposal that gets rejected, that person shapes what we know just as much as the one whose proposal gets funded. We just never hear about them. There's another thread worth pulling. Linguistic and cultural parallels between certain Filipino and indigenous American traditions have been noted by ethnographers, though these remain contentious. Similarities in mythological motifs, in agricultural practices involving similar crop types, in certain phonetic patterns, none of these alone constitute proof. Each one can be explained by coincidence or universal human tendencies. But when genetic data, maritime capability, cultural parallels, and geographic clustering all point in the same direction, the cumulative weight starts to feel significant. Not conclusive, significant. What does it mean for identity? This is perhaps the deepest question. For Filipinos, the idea that their ancestors might have been among the great voyagers who touched the Americas challenges a colonial narrative that portrayed pre-Spanish Philippine societies as isolated and primitive. The Spanish colonial framework, and later the American one, systematically minimized the sophistication of indigenous Filipino civilization. Evidence of transoceanic voyaging rewrites that story. It suggests a people of extraordinary navigational skill, courage, and ambition. For indigenous Americans, the implications are more complex. Many communities have their own origin narratives, sacred stories that explain who they are and where they come from. Genetic studies, no matter how well-intentioned, can feel intrusive when they seem to override those narratives with a Western scientific framework. The ethics of genetic ancestry research in indigenous communities remain deeply debated. The technician running the DNA extraction doesn't get to resolve that ethical tension. They just report what the molecules say. And the molecules say something unexpected. Here's what rarely gets discussed. In recent years, studies of ancient DNA, extracted from skeletal remains thousands of years old, have begun to confirm that the peopling of the Americas was far more complex than any single route model. Multiple waves of migration along different paths at different times. Some of those waves appear to carry genetic signatures consistent with coastal migration routes that connect to island Southeast Asia. The old Beringia-only model isn't wrong. It's incomplete, like a map that shows only the highways but ignores every coastal road. Now the twist, the detail that reframes everything. The most compelling genetic link between Filipino and indigenous American populations may not involve migration to the Americas at all, at least not in the direction we assume. Some geneticists have proposed that the shared markers reflect a deep ancestral population that once lived along the coastal rim of the Pacific, a population that dispersed in multiple directions over tens of thousands of years. Some went west, becoming the ancestors of island Southeast Asians. Some went east, reaching the Americas along coastal routes long since submerged by rising seas. The connection isn't that Filipinos sailed to America. The connection is that both peoples may descend from the same ancient coastal civilization, a people so old that neither the Philippines nor the Americas existed as concepts in their world. The ancestor isn't Filipino. The ancestor isn't Native American. The ancestor is something older than both, something we don't have a name for yet. Look, the lab technician who first flagged the anomaly in the haplogroup data probably didn't think about any of this. They were just doing their job, staring at a screen, noticing a pattern that didn't fit. But that quiet moment of attention, that willingness to say, "This doesn't match what I expected," set in motion a rethinking of human history itself. The greatest discoveries don't always belong to the people who get the credit. Sometimes they belong to the ones who simply refuse to look away from an inconvenient data point. On the other hand, the ocean remembers what the textbooks forgot. And somewhere in the double helix of human DNA, ancestors we've never named are still speaking. We just have to learn how to listen.